Today we're going to be starting lesson 8.2, which is on simplifying square roots. Not only are you going to see numbers underneath the radical sign, you're also going to see variables and exponents underneath the square root sign also, and we're going to talk about what to do when you see those. If we are simplifying 5 times the square root of 108, there is a way to check it with your calculator, which I will show you how to do once we finish the problem. Now, if we look at what's underneath the radical sign, which is 108, I'm trying to find the biggest perfect square that will go into it. And if I test it out on my calculator, I know that 108 is 36 times 3. So the square root of 108 is the same thing as the square root of 36 times the square root of 3, which is given in your rule that is written up above. That's pretty much what that rule means, that you can multiply 2 square roots together to make one large one. Now, to simplify this problem, the square root of 36 is 6, but I have to remember that I have to multiply the 6 by what's on the outside of the square root already. So I'm going to have to take 6 times 5, which gives me 30, with the square root of 3 left over. Now, if I wanted to check this to make sure it was correct, I could type into my calculator 5 times the square root of 108 and write that number down. And then I could type in 30 times the square root of 3 and write that number down, and they should match up. So there is a way to check your answer with a calculator on these types of problems. If we look at the second one, we're going to simplify 6 times the square root of 80. So I'm trying to find the biggest perfect square that goes into 80, and it's 8. So the square root of 80 is the same thing as the square root of 8 times the square root of 10. No, it's not. 8 and 10 are not perfect squares. Let's try the square root of 16 times the square root of 5. Okay, the square root of 16 is 4. And we have to make sure that we take our 4 times the 6 that's on the outside of the radical, and 4 times 6 is going to give me my 24, with the square root of 5 left over. Once again, if you wanted to check this with your calculator, if you take 6 times the square root of 80 and 24 times the square root of 5, your answers should match up. All right, in example 2, we're going to introduce some variables with exponents. Now, all of the problems that we're going to do in example 2 have exponents that are even. And the rule is, if you take the square root of an even exponent, you cut it in half. And in class tomorrow, we'll talk about the reason why. But for our purposes right now, you need to know that if you take the square root of a to the 16th, you're going to end up with a to the 8th. But I'm just cutting it in half. The first thing I'm going to do, though, is break down 28. And I want to look for the largest perfect square, which would go into 28, which is 4. So I've got the square root of 4 times the square root of 7. Well, the square root of 4 is 2. I'm going to leave a little bit of space because I'm going to have to take the square root of my variable. And then I'm going to write the square root of 7. Now, like I said, when you take the square root of 16, you're going to divide it by 2 in order to take the square root of it. And 16 divided by 2 is 8, so a to the 8th comes out because you took the square root of it. So your final answer is 2a to the 8th times the square root of 7.